Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is the second part of our video related to system design, covering on system modeling and architecture design. So this video is specifically covering on the two parts here that had been highlighted, which is interaction model and structural model. Getting more details. Okay, let's look at the second perspective, which is interaction perspective that is captured through interaction models. Okay, interaction models helps to identify user requirement. Okay, so during requirement engineering itself, this interaction model is actually being used. All right, and it is actually being used again during the design, where it is being made more detailed. Alright, so in this interaction model, we can model system to system, okay, different system to another different system to highlight any communication problem. You know, when you are having communication or interacting with another system which is beyond your control, of course, along the way there might be some communication problem. Maybe some processes has been changed, okay, and you don't know because that system is beyond your control, okay. And then in the interaction model also, they will model the component interaction. Component interaction is the system that you are going to build. What is the sub component within it, okay. So it helps us to understand if the proposed system structure is likely to deliver, right, according to the defined performance or dependability. Okay, so this is more related to the inside of the system. This is between the system, right? In UML diagram, the diagram that is suitable to capture this kind of information is called use case diagram and sequence diagram. I know some of you already know this, but I need to explain this because there are half of the students in this class that is not covering on this content yet throughout their course. Okay, let's look at the first one, use case modeling. So it is actually being used during the requirement elicitation. Remember when we are doing requirement engineering, this is one of the first process where you are trying to gather the requirement, right? So this diagram is being used because it's not that detailed, and it can show clear tasks that is involved external interaction with the system. So we in this diagram we can actually know the user that is interacting with the system, what are other systems that is interacting with the current system, okay. So sometimes this diagram is too brief that it is normally come with additional description just to support the explanation. So this is how it looks like. So this is only showing partially, only parts of the use case diagram. It's basically showing who are the user, okay, what kind of activity is being done in the system. Okay. Alright, I've mentioned just now, normally the use case diagram comes with a set of documentation, additional description describing it. Okay, so it's actually having many format, but this one is basically, this table basically show the common information that normally appear in the use case specification or additional description. Here it tells you who are the actor. Actor is basically referring to the user. So description basically explain, in this case, when you do transfer data, what are actually happening. Okay, so what kind of data involved. Right, for example, in this case, patient personal information, because this is a mental patient, they also capture the treatment that the patient has undergone. Okay, stimulus basically explain who studied, who who start this process. Okay, response is basically telling you if you have done this process, what is the outcome. Okay, and comments basically describe more information. Okay, so this kind of information can be called use case description. It is supporting the diagram. Okay, so if you are using a use case, here you can actually capture what are the main function within it. That's why it says that this use case diagram is being used during requirement elicitation. Okay, so because it's capturing the main functionality of the system. For example, for this, this is only showing partially of the diagram. It's only showing for medical receptionists. Okay, what are the functionality normally done by this user or actor? Okay, so if this is a medical receptionist, it register patient, unregister, view patient information, transfer data, and contact patient. This is related to capturing interaction. So I've covered on use case diagram just now. Okay, let's see the second one, which is suitable to be used, which is called sequence diagram. Sequence diagram is also another diagram under UML. Okay, that is used to model the interaction. So this is a more greater detail that use case diagram just now only capture the processes, right? This one is actually a lot more detail where you are already talking at the level of what objects to be involved. Okay, so this is more detail that this information later on from this sequence diagram can be passed to the programmer, because this diagram can be used by programmer to help them to do the coding and to understand the process. Okay, a use case diagram shows the sequence of interaction. It shows what is done first, second, third for each use case. If there are many use cases, okay, so each use case represent one main function. Okay, for one main function, we have this sequence diagram that show, okay, what is the sequence of interaction, what is done first, second, third, and so on. Okay, so it looks like this. Right, so we know who are involved. So the sequence is actually shown from up to down. Okay, so we know that in here this is a sequence diagram for view patient information. View patient information is actually for one use case, and this sequence diagram is for one particular use case. Okay, then it is showing that, okay, first this medical receptionist will review the information, and then we report, and then maybe need to do some authorization. Okay, and then it will be, if the authorization is okay, you can see the patient information. If authorization is not okay, can access. Okay, so sequence diagram is actually showing the sequence of processes in greater detail, where it also discusses and represent what are the classes or object involved. So when you are talking about classes, so it means it's very detailed already. And basically what you see here, the processes is later on, they convert it into method name, as when you are creating your classes, right? uh, I think most of all of you have experience doing Java programming, where you have classes, and in that classes there are methods, right? So this is actually the methods in the class, right? So if you are able to reach this point, so you can actually give this diagram to a programmer, and that programmer can start doing the coding. Okay, so these are more example. So the way to read the arrow is from up to bottom, and just follow the flow of the arrow to show what's happening. All right, and so here basically on top here is actually the objects involved, and so here is actually the actor or the user. All right, so it's showing in this case, this is a sequence diagram for transfer data. Okay, just now you have seen view patient info, right? So this is referring to another use case, which is to transfer data, and the detailedness of the what happened in the transfer data is actually being captured here. Right, so what we have seen just now is the interaction model. Okay, uh, we want to know how the models interact with one another. Okay, let's look at structural model. Structural model, I mentioned just now, basically is showing the organization of the system in terms of the component. Okay, because system is big, so you need to breaking it down to several components, and structure model basically are interested to know how the components are being organized and the relationship between them. And structure model sometimes are being called static models. Okay, it does not show it only show the organization of the system. Okay, um, right. So when you are doing system architecture, it is actually closely related to the the components or the classes that you define in the structure model. Okay. In UML diagram, the diagram suitable to capture structural information is class diagram. Class diagram is, I think most of you have seen it when you have taken programming courses. Okay, so basically it's showing the attributes, the methods, how does the classes actually interact with one another if there are several collection of classes. Okay, you know, hmm, uh, okay, so basically at early stages, uh, you identify the objects and the classes, right? Okay, so in UML class diagram, you are able to show the association. Okay, what are the classes involved and how do they associated with one another? And you can, if it's this one is this is an example from the case study for the patient management system. So this one is showing what are the classes available, how does the classes react to one another. Okay, so it's showing the relationship between them, right? And I think you have seen this class, right? From if you still remember, class is a description about certain thing that you want to do, whereby object is more is actually capturing almost the same information but in a slightly different form, because object is showing the executable form of the class. Right, and I think you remember that when we are dealing with the class, there are concept of generalization, yeah, inheritance. So normally, you can generalize because some of these class sometimes they are related, whereby the more general data and also methods will be put in a superclass, right? Whereby the more specific one will be put in the subclasses. In the concept of generalization in object-oriented, whenever you are doing modeling, uh, we need to also consider whether there is the existence of generalization. Why this is important is because whenever there are changes and we realize that the changes is affecting certain class, and we know that that class, that collection of classes, um, uh, one of the classes is actually a superclass of the other, it's actually easier to see how the changes actually affect the superclass and the rest of the subclasses. Okay, I mentioned just now in the previous slide, in Java, the generalization is being implemented using class inheritance, where you add the word extend in the codes of Java. And then as in generalization, we have superclass and subclass. Okay, so in this slide, it is being called slightly different term, which is a lower class refers to subclasses, whereby the superclass is being called uh, higher level. Okay, so the subclasses, the lower level classes actually inherits all the attributes and operation of the subclasses. But if in the subclasses there is methods or attributes which is defined as private cannot be used by the subclasses. Okay, yeah. So just to recap what you have learned in the previous courses. So basically, if you have basically generalization is showing a hierarchy whereby the upper classes are the super classes. Okay, so the common attributes or methods will be put in the superclass, and a more specific one will be in the subclasses. Okay, in this case we have doctor in general, and then we can scope it down to hospital doctor or general practitioner. General practitioner is those sometimes they have their own clinic, okay, and it is they are actually under doctor, but there is also those doctors that work only in the hospital. Okay, they can further be scoped down, being customized, okay, to consultant and team doctor and so on. Okay, so if you make it great more detail, adding more data with attributes and methods, okay, so the subclass, for example, general practitioner, so can also use and use the name, uh, phone, and email data which has been specified in the superclass. Okay, if when we are talking about class diagram, there are actually many types of relationship, but we are not covering it all. What we have seen so far is the concept of generalization, and another concept is called aggregation. Okay, aggregation in class diagram is meant to show how classes that uh, yeah, sometimes normally they are in a collection are composed of other classes. We want to see how a class is composed of another class, and sometimes it is being called part of relationship. So I hope that you have seen this before, but maybe for those who have not taken system analysis and design, maybe this is new to you. So basically, if you see a diamond, an empty diamond like this, it shows aggregation association. So basically, it's showing a relationship between the classes, not to show this one is a superclass and this one is a subclasses, but it's basically showing that, for example, a patient record is composed, is made of one patient. Okay, and in a patient record, you can have more than one consultant. Maybe because this patient uh, go and see many um, consultant in the hospital, so this patient is capturing the data of more than one consultant. Okay, so it's basically to meant to show the relationship between the class.